Hi guys, welcome to this lesson. In this video I will walk you through the rules of exponents. Okay, I will give examples and explain all the rules of exponents, right? Okay, let's start with this first page here. It says lesson title: Mastering Exponents for the SAT. So in this lesson, what I will basically do is to give examples and explain all the rules of exponents. Now let's start with the first rule. Here is the summary of all the rules as far as the SAT exam is concerned. Okay, now first of all, what is exponent? Exponent simply means powers. Okay, you are raising a number to the power of another number. For instance, when we have 2 to the power of 2. Okay, this 2 here is called the base, and this one is called the power or exponents. The power or exponents. So take note of this. Now when you have a to the power of m, so m is the power and a is the base. Okay, so we'll now look at the rules one after the other and explain more on it. Alright, the first one is the product rule. Okay, it says whenever you have an expression like this, a to the power of m multiplied by a to the power n, as far as they are the same base, okay, you add the powers. For instance, you know that 2 raised to the power of 3 is equal to 2 times 2 times 2, right? Also 2 times 2 times 2 times 2 times 2 is same thing as, this is 1 2 3 4 5, is same thing as 2 to the power of 5. Now when you have something like this, 3 to the power of 2 times 3 to the power of 3, this is same thing as 3 times 3 times 3 times 3 times 3, right? Because this one is 3 to the power of 2 and this one is 3 to the power of 3. So when you multiply all together, you have 1 2 3 4 5, and this gives us 3 to the power of 5. Now to make this simpler, that's why we are having that rule: 3 to the power of 2 times 3 to the power of 3. This gives us 3 to the power of 2 plus 3, and the final answer becomes 3 to the power of 5. So in summary, for rule 1, whenever you have an expression like this, a to the power of m multiplied by a to the power of n, as far as the bases are the same and equal, then you should add the powers, and this will give us a to the power of m plus n. Now for rule number 2, okay, we just finished this one. Yeah, we just finished this one. So for the rule number 2, rule number 2 is the quotient rule, right? Now, when you have a to the power of m divided by a to the power n minus the basis, okay, use the first one minus the second one. All right. For instance, let's simplify 2 to the power of 3, okay, divided by 2 to the power of 1. Now, this rule says we should do m minus n. So this will become 2 to the power of 3 minus 1, right? And this will give us 2 to the power of 2. Now, the other way around, we can also solve this as 2 to the power of 3 divided by 2 to the power of 1. This is equal to 2 times 2 times 2, right? Divided by 2, because 2 to the power of 1 is 2. So this, we cancel this, and we'll have 2 times 2, which is 2 squared also. So this is 4. This one is also 4, right? So this is it for the quotient rule. Now let's proceed to the next one, which is the power rule. This is the power rule. Now, whenever you have this kind of arrangements, multiply the powers. A to the power of m, close brackets, raised to the power of n. So to simplify this, the rule says multiply the powers. So let me illustrate. Imagine we have 3 to the power of 2, then raised to the power of 2, right? Applying this rule, we'll have 3, then 2 times 2, which will become 3 to the power of 4. Okay. Now, when we have this again, 3 to the power of 2 raised to the power of 2, we can also solve this as, now starting from what we have inside the bracket, 3 to the power of 2 is 9, right? And 9 squared is 81. Okay, this one also is same thing as 81, because 3 times 3 is 9, 9 times 3 is 27, then 27 times 3 is 81, because 3 times 7 is 21, put down 1, carry 2, 3 times 2 is 6, plus 2, 81. So you can see that this and this gives us the same answer. So approaching it using what this rule says makes it easier and faster, right? Then let's go to the next rule, which is the zero exponent. Now, when you have a number raised to the power of 0, it is always 1. Okay, as far as it is a non-zero digit, right? So for instance, when we have 2 raised to the power of 0, this gives us 1. And many a times students will say it is supposed to be equal to 0. Okay, let's look at this example. For instance, we have this. Let's say you have 3 raised to the power of 2 divided by 3 raised to the power of 2. Remember, the quotient rule says we should subtract, right? Now when we subtract, this will give us 3 raised to the power of 2 minus 2, and now we'll be left with 3 raised to the power of 0. On the other hand, if we solve this using the second method, this becomes 3 raised to the power of 2 divided by 3 raised to the power of 2. This will give us 3 times 3 divided by 3 times 3, right? So this will cancel this will cancel this. At the end of the day, you have 1 1 1 1. Okay, so 1 times 1 is 1, and 1 over 1 is equal to 1. Now this is how we arrive at this rule, that when you have 3 raised to the power of 0, it is equivalent to 1. 3 raised to the power of 0 is 1. The reason is this problem gave birth to a solution in this form. The same problem gave birth to this solution in another form. So it doesn't mean that this solution and this solution are different, but it is the same solution that exists in different form, right? So they are both equal. Okay, so have this at the back of your mind, please. Whenever you have anything like a to the power of 0, it must be 1. 21 to the power of 0, it must be 1. 6 to the power of 0, it must be 1, right? So let's go to the next one. The next one is negative exponents. Okay, each time we have 2 to the power of negative 1, this is same thing as 1 over 2. Okay, let's give this example. 2 to the power of 3 divided by 2 to the power of 4. Applying the quotient rule, this becomes 2 to the power of 3 minus 4, and this is now 2 raised to the power of negative 1, right? So let's still use the other method to solve this. We have 2 to the power of 3 divided by 2 to the power of 4. Okay, this will give us 2 times 2 times 2 divided by 2 times 2 times 2 times 2, right? So this cancel this cancel this cancel this, and we are left with 1 over 2. So this problem gave birth to this problem. Look at the solution it produced. So this solution and this solution are both equal. So therefore 2 raised to the power of negative 1 is equal to 1 all over 2. Hence, anytime you have a raised to the power of negative 1, this is 1 over a, and a raised to the power of negative 2, this is same thing as 1 over a to the power of 2, right? Then also x to the power of negative 5, this becomes 1 over x to the power of 5. So let's go to the next rule, the fractional exponents. Now imagine you have 4 to the power of 1 over 2. Okay, now we know that 4 to the power of 1 over 2 is same thing as square roots of 4. Okay, this 4 can be expressed as 2 to the power of 2, right? Raised to the power of 1 over 2. So when we simplify this, it will give us 2, because 2 raised to the power of 2 times 1 over 2 is equal to 2 raised to the power 2 over 2. This gives us 2 raised to the power of 1, and this is 2, which is what we got here. So also, this is square root of 4 is 2, so 2 is equal to 2, right? Now, whenever you have a to the power of 1 over n, this gives us n root a. Okay, now another example is this. 8 to the power of 1 over 3. Okay, this is cube root of 8. Now 8 can be written as 2 to the power of 3, right? And this is 1 over 3. So this is cube root of 8. Now 3 times 1 over 3 is 1. So 2 is equal to, then cube root of 8 is 2. So cube root of 8 simply means what is that number that can be multiplied 3 times to give 8, right? So in summary, whenever you have a to the power of 1 over n, this n will be here, root a, right? Then for important notes, when we have a to the power of m multiplied by b to the power of m, you can write it in this form: a and b in the bracket, then since they have the same powers, you put the power outside. Let me give an example here. Let's say you have 2 raised to the power of 2 times 3 raised to the power of 2. Okay, 3 raised to the power 2 raised to the power 2 is 4, right? And 3 raised to the power 2 is 9, and 4 times 9 is equal to 36. So let's rewrite this now in this form. So 2 to the power of 2 multiplied by 3 to the power of 2 is same thing as 2 times 3 raised to the power of 2. Okay, raised to the power of 2 because we are taking the common powers here. So 2 times 3 is 6, and 6 squared is 36. Same thing, same answer here. Then for the second one, same thing here, but this one is quotient. Or when you have, for instance, 2 to the power of 3 divided by 2 to the power of 3. Okay, they have common powers, though the you have 2 to the power of 2 divided by 2 to the power of 3. Okay, no, 3 to the power of 2, 3 to the power of 2. Okay, this is same thing as 2 over 3, then you take the common powers, right? So the same thing here, 2 to the power of 2 over 3 to the power of 2, you take common powers here, you still get the same thing. Then the last one is common mistakes that students make with their exponents. Now, many students, we say any number raised to the power of 0 is 0. Okay, that is not the case. So every student must have it at the back of his mind that a to the power of 0 is 0. Okay, just like we proved before. If you have 2 to the power of 2 divided by 2 to the power of 2, this is 2 to the power of 2 minus 2, and this is equal to 2 raised to the power of 0. Also, when you solve it in a different form, 2 times 2 divided by 2 times 2, this will give you 1. So this result must be equal to this result, and that's why we say 2 to the power of 0 is equal to 1. Then for the second one, at times when students are solving question of this form, they are quick to separate it by writing it in this form: a squared plus b squared. No, these two can never be equal. Okay, for instance, let me use an example. Let's say this is 2 and this is 3. So 2 plus 3 to the power of 2, and a student is writing it in this form: 2 to the power of 2 plus 3 to the power of 2. They are not the same. Okay, they are not the same. Now let's simplify this one. 2 plus 3 is 5. 5 squared is 25. Then here 2 squared is 4, and 3 squared is 9. 9 plus 4 is 13. So these two cannot be equal. However, when you have 2 times 3 raised to the power of 2, okay, we can rewrite it as 2 squared times 3 squared. Okay, so let's simplify. 2 times 3 here is 6, so this gives us 6 squared. Then 2 times 2 here is 4. 3 times 3 here is 9. 6 squared is 36, and 4 times 9 is 36. So it is only when we have multiplication sign that we can be rewritten in this form. Okay, now let's go back to the last one there. So for the last one, which is number 3 of these common mistakes that students make, now you are having 2 to the power of 2 times 3 to the power of 3, and a student is adding this 2 plus 3, 5. These are common mistakes. So to add these powers, this base and this base must be equal. If they are not equal, then solve them independently. That is to say, to solve this correctly, this is supposed to be 2 to the power of 2 multiplied by 3 to the power of 3. This becomes 2 to the power of 2 is 4 times 3 to the power of 3 is 27. Okay, and 27 times 4 is equal to 108. So you can see that 108 cannot be equal to 6 raised to the power of 5. Right? So I wish to thank you for watching this video to this moment. Please like, share, and comment. All right, and I hope to see you in my next lesson. Thank you so much, and goodbye.